Understanding force, the push and pull of physics. Have you ever played tug of war? Or pushed a heavy box across the floor? You were using force. In simple terms, force is a push or a pull. Force makes things move, stop, or change direction. Imagine hitting a tennis ball with a racket. You apply force to the ball, making it move and changing its direction. Forces are all around us. We use force to walk, talk, and even breathe. Without force, the world would be a very different place. Understanding force is key to understanding how the universe works. From the smallest atom to the largest planet, everything is governed by the laws of motion, and it all starts with a simple push or pull. Diverse forces, familiar actions, contact versus non-contact. Forces can be classified into two main types: contact forces and non-contact forces. Contact forces happen when objects physically touch each other. Think about kicking a football. Your foot directly contacts the ball. Other examples include frictional force, tension force, and normal force. Non-contact forces act from a distance, with no physical contact. A great example is gravity. The Earth's gravity pulls on you, keeping you on the ground. Other examples include magnetic force and electrostatic force. Think about a parachute slowing down a skydiver. Air resistance, a contact force, opposes the downward pull of gravity, a non-contact force. Fascinating, right? Newton's first law, the law of inertia. Objects at rest. Sir Isaac Newton, a brilliant physicist, developed 3 laws of motion that explain how objects move. Let's start with Newton's first law of motion. This law states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. This means an object at rest won't move unless something pushes or pulls it. A book on a table won't suddenly fly off unless a force acts upon it. This tendency to resist changes in motion is called inertia. The heavier an object, the more inertia it has. This is why it's harder to push a car than a bicycle. The car has more mass and therefore more inertia. Section 4. Newton's first law, inertia in motion. Objects in motion. Newton's first law also applies to objects in motion. Imagine riding your bike. You'll keep moving at the same speed and in the same direction unless you pedal faster, brake, or hit something. This means a moving object wants to keep moving in a straight line. That's inertia too. When a car suddenly stops, your body wants to keep moving forward, which is why wearing seatbelts is crucial. Think about a ball thrown in space. Without gravity or air resistance, it would travel forever in a straight line at the same speed. That's inertia in action. Section 5. Newton's second law, force, mass, and acceleration, F equals sine ma. Newton's second law of motion explains how force, mass, and acceleration are related. It states, force equals mass times acceleration, F equals sine ma. This means the greater the force applied to an object, the greater its acceleration. Push a shopping cart harder, and it will accelerate faster. Mass also plays a role. A heavier object will accelerate less when the same force is applied. Pushing a full shopping cart requires more force to achieve the same acceleration as an empty one. Let's say you apply the same force to a tennis ball and a bowling ball. The tennis ball will accelerate much faster because it has less mass. The bowling ball with its greater mass will accelerate much slower. Section 6. Newton's third law, action and reaction, equal and opposite. Newton's third law of motion states, for every action, there is an equal and opposite reaction. This means whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Think about jumping on a trampoline. You exert a downward force on the trampoline, action. The trampoline exerts an equal and opposite upward force on you, reaction, propelling you into the air. Another example is swimming. Your hands push water backward, action. The water pushes your hands forward, reaction, propelling you through the water. Understanding Newton's 3 laws of motion helps us understand how objects move and interact with each other. These laws are fundamental to physics and have countless applications in our daily lives.